So it's actually a good timing. Now, just to let you know, we'll do 6-6 tomorrow, 6-6 on Thursday, and my plan is to go ahead and tell you now. Let's do a section 6-1 through 6-7 quiz Friday, and then we have the 3-day weekend, kind of relax, decompress, not have to worry about stuff, and then go from there. So we'll do a cumulative quiz on Friday over the sections 6-1 through 6-7.
How many more are there?
I think there's probably another 6 or 7 sections and stuff. So, but to me they get easier because they are they're just the algebraic way of doing it, not this crazy summation kind of crud stuff. So today we get to talk about the behavior of accumulation functions. So when is it increasing? When is it decreasing? And that kind of stuff there. We get to talk about concavities and so forth. As we look at our accumulation functions, how can we look at a graph and tell where certain things are occurring and so forth. So, where is the max? Where is the min? Where is it concave up? So, again, quick little bit of notes. It's not much. Just this first page and part of another one. It goes pretty quick there. The accumulation functions that we've been talking about are in the form of capital F of x, which is the antiderivative we learned about yesterday. The antiderivative of an integral from a constant to a undetermined amount x of some function. We recognize that if I'm trying to find the derivative of capital F, well, that's just the original function. The derivative of the antiderivative is just the original function. Today we're going to review some of the stuff that we did in Chapter 5 as we analyze parts of the first and second derivative. So, f of x, so the antiderivative is increasing. Well, when is that occurring? Well, capital F of x is increasing when f prime of x is greater than 0, so when it's positive. So when the derivative of capital F of x is positive, we know that capital F of x is increasing. When is it decreasing? Well, that's when capital F prime of x is less than 0, so when it's a negative amount. When we're looking at capital F of x, when does it have a relative max? Well, we got to think about, what does a relative max mean? That means that I change signs from what to what? Positive, negative. So it has a relative max when capital F prime of x changes from positive to negative. And now we can go ahead and fill in the next one. When would I have a min? When capital F prime of x changes from negative to positive. How would I know that I'm concave up? As we're looking at the notation we're using, what derivative would be associated with that concave? Yeah, the second derivative. So we would want to change this to say, well, it's concave up if capital F double prime of x is greater than 0. It is concave down when capital F double prime of x is less than 0. And then how do I know I have a point of inflection? I do what? Yeah, it's where we change signs with f double prime. We change signs, so f double prime of x changes signs. And again, just as long as it changes signs. So we don't have to worry about the order. If it changes signs, f double prime, capital F double prime changes sign, then we know that there is a point of inflection there. Now, that's one way you can do it. Or we can say as follows. F of x is greater than 0. F of x is less than 0. And then again, we're just changing these back to, because we know that the derivative of capital F prime is just f of x, so we can replace those things with just f of x. We would change positive to negative, and then it's a minimum when f of x changes from negative to positive. We are concave up when f prime of x is greater than 0, and when f prime of x is less than 0. And then it would be f prime of x changes signs. Again, just to give you a way to confuse your brain, I would say just whichever one makes sense, kind of focus on those ones and stuff. We're not going to do a lot of switch it up in a problem in the display of stuff. As we go to the next part, they're telling us that let g of x equal to the antiderivative from a to x of f of t dt, where f is shown in below and a is a constant. So what this picture is. Now, what we also want to realize is that this is also g prime, is what this is. That's the f graph, but it's also the g prime graph, is what we can consider. Okay. Because again, it goes back from the standpoint, g prime of x is equal to f of x. All right, if g is equal to the antiderivative, when I take the derivative of g prime, that would be the derivative of the antiderivative, which is just the function. So, now, they ask us to figure out some things based on this graph. They ask us to go down here and tell, hey, what is the relative minimum value of g? Where is there a relative max? When are we concave up and all this other stuff here? So we'll go through one at a time. So when is there a relative min of g? That would mean I have to change from negative to positive. So where are we changing on that graph from negative to positive? Somewhere about there? Okay. So somewhere about here, we go from negative to positive. So somewhere around x is approximately maybe 5.5, maybe somewhere around 5.4. It looks like it's a little bit less than the halfway mark, just a smidge. So something like that. Most of the other times, like as we do some of these other ones, it's going to be a clear cut whole or integer amount, a whole integer or whole number. Relative maximum of g. Well, to be a relative max, that means I change from positive to negative. So that would be right there. That's where I'm going from positive to negative. So that means at x equals 3, I have a relative max. Where is g concave up? Well, that would be where f prime is positive or g double prime is positive. So on what interval is f prime positive and g double prime positive? Who wants to take a stab at that one? If that's the graph of f prime has got to be positive, so that would mean that the what's positive? What'd you say? So yeah, the slope's positive. So what interval has a positive slope, Jeffrey?
4 to 6.
Yeah, 4 to 6. Okay, so we are concave up from 4 to 6. Okay, because we have a positive slope. Again, trying to piece all those things together. Okay. Where is the interval? Where is it going to be concave down? That would be when f prime is less than 0. So where is slope negative? And that would be from 2 to 4? Okay. I think is what I heard you say. Thank you. Where is there a point of inflection? So where do I change? Where does f prime change signs? Well, right there is where f prime changes signs. We went from positive to negative. So at x equals 4, I have a point of inflection. Now, if g of 1 is 5, what is the maximum value of g on the interval from 1 to 5? Okay. So where does the max occur again? At what x value? At 3, right? Didn't we say the maximum was at 3? All right. So what we're going to say is we have our interval from 1 to 3 of our function. Now, there is an initial amount. What did they say? What did they say g of 1 was? 5. So then we technically have a 5 plus, since we know the amount up until 1 is 5. Now we're just got to figure out what is the extra bit. So we more or less, we know all this area here in a way is 5. We got to figure out this extra bit right here. So it looks like I have 5 plus. Ooh, ladybug's still alive. I'm going to put you out there. You're going to freeze to death. So we get to go one whole unit here, another whole unit. And doesn't it look like this little piece here and kind of fits into that missing piece? So it looks like we're adding 3 for that little part there. So our maximum value would be 8, is what it would be. And that's it on that part. Now, I know it says on the interval we're not going out to 5. We're just going up to where that maximum value occurs is where we're going to. Okay? That's the hard part, is because it said over the interval. And so we're thinking we got to go through the 3, 4, and 5, but we don't have to. We just want to go up to where that maximum value is occurring. Okay? So, this is the max value. And then we're just trying to figure out, well, what is that amount? Yes?
So if it didn't have a maximum, just said value, we go out to 5?
Yeah. Then that would be more like, what's the area? Like the previous sections would have said, yeah. Okay. So, I would say if they, granted, that's past it. That's why they didn't do it on this one. You may see one that said, hey, the minimum. So that would be going all the way over to that 5.4. And then we would actually subtract those bottom ones off of it. If they're saying, hey, what's the minimum value? It would be going all the way out to that part. Okay. But again, they chose not to because they had that ugly X value is what they had. And they had that curve, which had been hard to make, areas of with triangle stuff. So last one, last practice problem here. It says, let g of x equal the integral from 0 to a function of f of ft dt, where g is the graph shown to the right. Find the x value where g has a relative maximum. Okay, so again, relative max is when g prime changes signs. So where do I change signs? Yeah, 3. All right, this is where I'm changing signs again. So, we got to figure out. Okay, so what would if I know g of x, is equal to this thing here, And we have the x over 2 plus 5. What would the g prime be? What would g prime be? What would that look like as an equation? Wouldn't that be f of x over 2 plus 5? And then I got to do it times what? Since the upper bound is a function, I would multiply by what? Yeah, the derivative of it. So what's the derivative of that? Yeah, 1/2. Okay. So, all right. So I'm just trying to read my chicken scratch from last night as I fill out all over the place. So now what we got to go through and do, I better be better at writing my little notes here so I can remind me to do this, do this, do this, do this. That's what I get better at. So now they say find the x value where g has a relative minimum, or I'm sorry, maximum. Somewhere I saw minimum in that word. Don't know why I saw that in there. Okay. So, so now what we need to do is we need to say, okay, when is f of x over 2 plus 5 equal to 0? Well, it's equal to 0 at 3. So we want to figure out when x over 2 plus 5 equals 3. And then now we just get to solve. So that would be x over 2 equal to negative 2. Multiply both sides by negative 2, and I get x is equal to what? Negative 4. So at x equals negative 4 is our x value where we have a relative max based on that tweaking when they to give us a function for the upper bound. So I don't think we have a lot of practice problems that are that crazy. So, you know, I notice on on the next one it looks like each of the I's on the practice problems have that kind of little crazier stuff. So if you need to look at some of those things when you get to them, holler at me. Okay? So I'll try to get ahead of you and go ahead and work some of those. That way you can look at it as you do it. But that's pretty much about it. Nice, short, sweet. I like more of the lessons that are coming in the next couple lessons. There's a lot nicer. Okay, so you guys are free to work with each other. I'm going to keep recording. That way I can put some of this down for those that are absent as we're doing things. So. Ooh, Yo, man.
I have two questions. Can you go up to the last question real quick? So,
That-
no, the one below that. That one. So, I'm looking at the graph,
Yeah.
and so there's a point on the slope that's positive, where it like kind of changes at 3-1. Would it still be considered concave up? Because the F prime is positive the whole time. But I don't know if that would be a point where it would like all the way up to 4. So would it be?
So you're wanting to know, okay, is from 3 to 4, is that concave up or concave down?
Yeah, I think it's
That's right.
concave up, but it's like, would I include that all as one number or make it two separate intervals? The infinity, would it be infinity to 4 or infinity to 3, 3 to 4?
To 4.
Okay.
To 4, because it is technically still increasing. It's just, because it is positive when you know, because it is technically increasing on here. You know, so that is technically increasing, so the derivative would be still positive.
So when you say,
So it'd be concave up.
Okay, but.
And
the
then,
concave
so
down is-
yeah, so technically from infinity to 4, it's concave up, and then,
4 to 5 and 6 to negative infinity, or
Yeah.
positive infinity?
yes, would be the concave down.